Atomic bomb, also called atom bomb, weapon with great explosive power that results from the sudden release of energy upon the splitting or fission of the nuclei of a heavy element such as plutonium or uranium. When a neutron strikes the nucleus of an atom of the isotopes uranium-235 or plutonium-239, it causes that nucleus to split into two fragments, each of which is a nucleus with about half the protons and neutrons of the original nucleus. In the process of splitting, a great amount of thermal energy, as well as gamma rays and two or more neutrons, is released. Under certain conditions, the escaping neutrons strike and thus fission more of the surrounding uranium nuclei, which then emit more neutrons that split still more nuclei. This series of rapidly multiplying fissions culminates in a chain reaction in which nearly all the fissionable material is consumed, in the process generating the explosion of what is known as an atomic bomb. Many isotopes of uranium can undergo fission, but uranium-235, which is found naturally at a ratio of about 1 part per every 139 parts of the isotope uranium-238, undergoes fission more readily and emits more neutrons per fission than other such isotopes. Plutonium-239 has these same qualities. These are the primary fissionable materials used in atomic bombs. A small amount of uranium-235, say 0.45 kilograms, 1 pound, cannot undergo a chain reaction and is thus termed a subcritical mass. This is because, on average, the neutrons released by a fission are likely to leave the assembly without striking another nucleus and causing it to fission. If more uranium-235 is added to the assemblage, the chances that one of the released neutrons will cause another fission are increased, since the escaping neutrons must traverse more uranium nuclei, and the chances are greater that one of them will bump into another nucleus and split it. At the point at which one of the neutrons produced by a fission will on average create another fission, critical mass has been achieved, and a chain reaction and thus an atomic explosion will result. In practice, an assembly of fissionable material must be brought from a subcritical to a critical state extremely suddenly. One way this can be done is to bring two subcritical masses together, at which point their combined mass becomes a critical one. This can be practically achieved by using high explosives to shoot two subcritical slugs of fissionable material together in a hollow tube. A second method used is that of implosion, in which a core of fissionable material is suddenly compressed into a smaller size and thus a greater density. Because it is denser, the nuclei are more tightly packed and the chances of an emitted neutron striking a nucleus are increased. The core of an implosion-type atomic bomb consists of a sphere or a series of concentric shells of fissionable material surrounded by a jacket of high explosives, which, being simultaneously detonated, implode the fissionable material under enormous pressures into a denser mass that immediately achieves criticality. An important aid in achieving criticality is the use of a tamper. This is a jacket of beryllium oxide or some other substance surrounding the fissionable material and reflecting some of the escaping neutrons back into the fissionable material, where they can thus cause more fissions. In addition, boosted fission devices incorporate such fusionable materials as deuterium or tritium into the fission core. The fusionable material boosts the fission explosion by supplying a superabundance of neutrons. Fission releases an enormous amount of energy relative to the material involved. When completely fissioned,